Hi, hello, and welcome to another episode of Indoor Environments. I'm Bob Krell. I'm the founder and publisher of Healthy Indoors magazine, and I'm joined by Don Weeks, who is the president of the Indoor Environmental Quality Global Alliance. Welcome, Don.
Good morning. How are you today?
I'm doing well. I want to point out that this show is a joint production of ISIAC, the International Society of Indoor Air Quality and Climate, and the Indoor Environmental Quality Global Alliance. So, how are things in Ottawa today?
Nice and rainy. So we're getting a lot of rain the last couple of days.
Uh,
But other than
us
that, it's nice fall.
Us too. I mean, we're only like a couple hours apart, so it's
Yeah.
Syracuse is rainy and gloomy today too. So anyway, we have a great show today. We're going to be talking
Mhm.
about personalized environmental systems, which I think is just really fascinating technology and something that's probably going to be a lot more prevalent in our future. So I'll,
I'd
I'll let
agree.
you do the introduction of our guest, Don.
Yes, welcoming Dr. Bjorn Olsen to the show. Dr. Olsen is a professor of the International Center for Indoor Environment and Energy, Department of Environmental and Resource Engineering in the Technical University of Denmark. He heads one of the world's leading research groups related to the influences of indoor environment on people. Welcome.
Thank you.
Hello.
And hello here from Copenhagen. It's sunny and nice, no rain.
Wonderful, wonderful
Perfect.
Copenhagen. There you go. So I wanted to start with a little bit of background on you. You have a master's degree in civil engineering and a PhD in laboratory of heating and air conditioning from Technical University of Denmark. How did you become interested in indoor air quality and in particular PECSs?
Well, my start on indoor environmental quality was my late Professor Thanger, which a lot of people knows in this. When I still was studying, he asked if I needed a summer job to help him running some experiments. And I said yes, and since then I have worked with the influence on people of the indoor environment. At that time, we were very much focused on the thermal environment, and then later we also focused on the indoor air quality.
And how does these personalized exposure control systems work, or environmental control systems work? What are they, and how do they interact with the indoor environment?
Yes, the reason why we of course got interested in that is that we could see from our basic study that there are large individual differences from what you prefer regarding temperature and ventilation and other stuff. So we have always looked for how can we make the indoor environment more individual, and in this way get more people satisfied with the indoor environment. And a personalized system means it's a system which can control locally on the individual thermal comfort, air quality, lighting, and acoustic. Now, not necessarily all the four parameters at one time. You best know, I think, as a personalized environmental control system, a simple desk fan.
Mhm.
That is really under your own control, and that can give you some increased air velocity, that can give you a little cooling when it gets hot. You can also take task lighting as an example of individual control system. But what we are looking for is, of course, you're really dealing with all these four parameters.
So you mentioned Dr. Thanger. I remember his lectures back in the 1980s and 90s. He was talking about those types of systems in that time frame, if I remember correctly. And as you say, you worked with him on on some of these type of tasks. So your center there has been working on this for more than 20 years, 25 years actually.
Yes, even longer. Was around the energy crisis in 73.
Mm-hmm.
One of my colleagues, he constructed a heated chair and could show that using this chair, you could lower the ambient temperature a couple of degrees and then save on the general heating. So that was already in the 70s. We kind of started looking at it, but it was later where it really took off in the 80s, especially one of my colleagues, Professor Arsen Melikov. He has driven a lot of the research we have done on personalized system, and he worked especially on what we call personalized ventilation.
So how does a personalized ventilation look other than the fan that you mentioned? It goes beyond that, I would think. What else, what does it really look like?
Yeah, there are different types of systems. Very much you work with what we have worked with very much in detail is the personalized ventilation, because normally when you ventilate the whole space, but people are only using maybe 1% of the outside air. The rest, you could say, is waste. So if you could give the outside fresh air directly to the breathing zone of people, then you could save a lot of outside air, and in that way also energy. So one system look so that each workplace, they have an air outlet, an air supply directly with fresh air, which they can control the direction, maybe the amount of airflow. And what you have to look at here is normally when we have an air outlet for a air conditioning system or ventilation system, we often want to have entrainment of room air, so we get a complete mixing. But in our case here, we want that the fresh air goes directly to the breathing zone without any room air getting into it.
Mm-hmm.
So you have to look at this aerodynamics, fluid dynamics to get that correct. Another thing, technical thing, is that people, when you're sitting, you're warmer than the environment, so you create an airflow along your body, and you have to break through that. So the air velocity has to be high enough to break through that, so you get the fresh air. But on the other hand, it cannot be too high, because then people are complaining about draft. So one symbol is, it's not simple, just to provide clean outside air directly to the workplace.
So I'm assuming that the diffusers or discharge diffusers would be configured totally different than in a conventional heating and air conditioning system, right? Where normally in an office environment, they're usually ceiling mounted and they're four directional, and they're dispersing everywhere. So this is, I'm assuming the discharge is close to the occupant.
Yeah, it's normally there has been work on many different ways to find what is the optimal position of the outlet, and of course it's much smaller. We are talking about 10-15 centimeters in diameter. So but you have to make it so, as I said, so you don't get so much entrainment of the room air, but it also has to be there so it doesn't disturb people.
Mm-hmm.
So what we have seen is the best position is a little above the head of the person, and then the air is directed towards the breathing zone. So of course, this type of system is for people who have sedentary work. of course, if people are moving around, it will not work.
I was wondering when you say that they personalize a system, and you mentioned fresh air from, assume from the outside. Climate outside will, vastly change over a period of time in many cases. Especially places like like Denmark and in Canada and even Syracuse. Sometimes it's too hot and sometimes it's too cold outside. How do you model? How do you get that into a personalized system? What do you have to do to be able to use that outside air?
Yes, that's you could say that's one of the difficult things. Now, when we talk about, we'll talk a little about later about the thermal side, heating, cooling, but let's just talk about the, let's say, the air quality and the breathing of fresh air. You're right. You need to have conditioned air, because the temperature of the air you breathe has a significant influence on how fresh you feel it. So normally you would take the air when it has been either preheated in winter or pre-cooled in summer. So it goes you can say, through the general system. And that has been one of the problems, because then to get the kind of ducting to each workplace, and so it looks good architecturally, the environmental design looks good, is complicated and can also be costly. But if you take, for example, I know it's pretty popular in the US in office building, but also in Japan, a raised floor, underfloor air distribution.
Mm-hmm.
If you're using this type of system, then it's more easy, because you can, for each workplace, you can just put a duct down in the plenum, and then you will get an air at a conditioned temperature.
Interesting.
There are then possibilities that the system itself, like a desktop system, could have some built-in heating, so you can adjust the temperature individually of the air that you are getting. So that is a possibility. You could use electrical heating for that. But normally we would serve the air cooler than the environment. If the air starts getting warmer, then warm air tends to go upward, and you may not reach the breathing zone. So the temperature of the air has also an influence on the efficiency, how you reach the breathing zone with the air. But one thing we are looking at nowadays is also maybe you can use cleaned room air.
Mm-hmm.
So you just have air cleaning at the work desk. When we talk about particles and filtration and virus, which are particles, you can have a good filter, so the air you breathe has been cleaned. There's also other gas phase air cleaning. You want to kill bacteria, UVGI. So there are some possibility, maybe not to serve outside air, meant to serve cleaned room air, which I think have some possibilities in the future. And there's some things we are working with also at the moment.
Well, in many places around the world too, the outdoor air is not cleaner than the indoor air. India, where bringing in outside air is not fresh air; it's highly polluted air.
Yeah.
So in that environment, you're recycling, maybe gas sorbent type filtration.
Yeah. Yes. But that's relatively new that we have started with that, and critical is here how much energy you're using for that, because we don't really want to increase the energy use with personalized system. One of the idea we had is you can decrease energy use for heating, cooling, ventilation, because we use less air. But if we start using a lot of energy because we have a big pressure drop over filters in the individual systems and so on, so the energy balance is something you have to look at also when you do the systems.
So I noted at the recent Climate 2022 conference, you and your colleagues presented a paper entitled Development and Initial Testing of a Personalized Environmental Control System. Can you tell us a little bit about the findings of that paper?
Yes, this was is a development we are doing on this year is like a desktop system, which will have cleaned room air. It could also be outside air, depending on your ambient system. If it's easy to get the outside air to each workplace, you can use that. But we're also working with the possibility to have a cleaned room air. And on this system, we also have heating. Often people, when they complain about getting too cold, is often on the lower part of the body. So the heating system is focused on heating the lower part of the body. So under the table, we have panels, radiant panels for heating. So you use electrical energy for have a radiant heating on the lower part. We also looked at using different forms of radiant heating. So, and then we had the ventilation, the personalized ventilation. And here, one of the things we wanted to look at was if it's possible to cool the supply air. Cooling is always the problem. It's easy to heating because you can use electrical heating, but cooling is a bigger problem. So we were working with an idea of using something called the Peltier effect, where you also by having a current or electricity can make so you cool down, but then you also get heat you have to get rid of, because that would help in satisfying the individual differences. So we were doing a testing of such a system. How efficient was the heating? Could we obtain any, let's say, cooling by this electrical Peltier effect? Or how was the cooling you got just by the air velocity from the air? So that was something we studied. And what we study is often we study first, we have a thermal mannequin. That's a you could say it's a normal kind of display mannequin you're using for dress up with clothing. But these mannequin we are using, they are equipped with a surface heating system, so they simulate the same surface temperature as a human being. So this effect of the warm body, when we do measurement, we can use this mannequin to simulate the human being. So we had a study here with many subjects who also gave response on the performance. So what we found was that for the heating part, for the thermal comfort, we could significantly change the perceived temperature. And we were looking at a new radiant panel, which was like rounded, so it had a bigger angle factors to the body. But what we also found was that the cooling of the supply air did not work as it should. We didn't get enough cooling. Some of the electronic that was built into the system heated up the air again. So this construction was not working well. So I think that was some of the goal, but also some of the things that came out of this, and we got then some idea to continue the development or make it more efficient.
So so the cooling devices, they were localized at the outlet point near where the
Yes,
occupant was. So
yes.
the heating and cooling was all taking place right in
It
that.
was cooling, heating and cooling. It was
Centralized
cooling
unit.
of the air that was supplied. The heating was not heating the air, but it was like a radiant heating panel
Just to
you had.
provide heat on the lower part of the body.
Yes,
So okay.
yes, like under the table.
Mhm.
Yeah.
Well, it sounds interesting. You expect, I imagine, to do much more research on these types of units and make some changes, particularly with regards to the cooling portion of this device.
Yeah. The cooling is the tricky thing. Of course, you can get by increasing airflow, you will get some cooling. But the airflow we are normally using is an airflow directed towards the breathing zone, so it will not hit a big surface area of your body. So if you only wanted the cooling effect of the air velocity, a table fan would probably give you more cooling than the air outlet with the cleaned or fresh air.
And you have a diminishing return with that too when you're blowing the air in somebody's face, because you can only have so much velocity, and then
Yeah.
that's perceived as uncomfortable by the occupant.
Yes, it's one thing is this is personal control.
Oh.
So what the occupant accepts and so is a little different than if somebody enforce it on them. They are more inclined to accept higher air velocity if they have the control. But there is an effect if you have an air velocity in your face for a longer time, it may dry out your eyes, so you feel discomfort for this reason. So they are limited to how much air velocity you can expose on the face. Yes.
Interesting. So my understanding that these PECSs have been in use since the early 2000s. However, there's not been widespread use of these. Can you tell us why they have not been implemented in more workplaces?
Yes, there has been systems on the market. One of the first that was on market was from a major US company selling control, ventilation, and air conditioning. And they had, this time it was called a task ambient system, where you could have some white noise, you could have increased air velocity, there was some electrical heating, and there was lighting. So it was like a work station. And it was on the market, but I don't know when it was taken off the market again. I think one problem was it was not really for ventilation. You could increase air velocity, but you didn't get fresh air, so it was not very much focused on the indoor air quality. But it was a system on the market. We had in Denmark an European ventilation company who also had a system on the market. They went on the market in 2008, but that was just the time where all new buildings stopped. So it was not a good time to come on the market with a system which were, I think the first cost would be more expensive than a general AC and ventilation system. So we had some installation, among other, in Syracuse at a bank, and we had also 2 banks in Denmark where people are sitting often at their PC and desk the whole time, and they worked satisfactorily. We had a study also to find out the acceptance, and everybody was satisfied by using this system. But the sales was not high enough, so it could go on the market. So now there are many. We just started. The International Energy Agency have a group called Energy in Building and Communities, and they have different annexes with work with different topics related to energy and indoor environment. And we just started a annex on a personalized environmental control system. As I said, research has been going on for 10, 20 years. So with this, we are now trying to gather all people from around the world who has done some research or doing some research on this, and in this time combined our efforts to make it more applicable in practice in the future. And there's a big interest in this annex, which is just started. I think for the first meeting, we had more than 60 people from all over, from Asia, US, and Europe. So we are now really trying to give a push for these type of systems. And we have talked a lot here about heating and ventilation. We are also, but it's not talked about so much, also have the lighting and the acoustic. On the acoustic side is, of course, you don't want to make noise with a personalized system. But where it could be used is you could have masking noise in open plan offices, so you're not disturbed by the other people. Task lighting, as I said, is one of the first personalized system you can think about. But today you can do a lot with lighting. You can have light therapy. You could give people a special type of frequency light sometimes during the day, which may have the same effect as going out in the sunshine. We have seen that the color of light has a short-term effect on people's perception of warm and cold. So you could think about when people come to work, they are a little high activity. In the first half hour, give them a little blue light so they feel a little cooler. But it is a short-term effect. We are talking about half an hour or so. Some people think you have a long-term effect, but you don't. So I think there are many interesting things also with personalized light, which in the future can bring such systems forward.
That's fascinating too. So, and with the personalized lighting, would that be something that would be automated to the extent that it would be since an occupant comes in the space and maybe changes the color temperature based on a timing interval?
I
So that
think
would be something that they wouldn't necessarily be fiddling with themselves, right, in real time.
no, and yes. I think it would be automated in a way that it will be pre-programmed or whatever. But then if people one way or other don't like it, they should be able to interfere and change that. But I think we are working a lot with the control, and we had you just talk about the paper at the Klima conference. We also had another paper which were looking more on the automatic control and personalized system, and going in the direction what they do in the automobile industry. How can we take into account the individual who is sitting now at the workstation? Can we make a personalized comfort? Nowadays, when we design our indoor environment, we design mainly for an average person. First of all, we don't know what type of person comes into the space, and you may have several persons in the space. So we're looking at an average person. but we would like to control and design for an individual. So we would like to see how can we make this control more automatic by having sensors for the environment, but also have personalized sensors of skin temperatures as one parameters. So the second paper was really to look at a kind of personal comfort model. So by some personal indicators, it could be skin temperatures and others, it would recognize which person is sitting there. And to get data for how this person wanted, you need to use machine learning, artificial intelligence. So by time you learn to know this person, and now you can make it much better automatic control. But it should always be so the person can interfere, can go in and change if they want. You know it from the car industry. They are also working with that. So the indoor environment in the driver's seat and in the passenger seat can be quite different, and
Sure.
it recognizes now who is now driving from the key. Is it the wife or is it the husband? And setting the settings accordingly. So this is something we were working with in the second paper to start looking at this.
And that's a big factor for occupant comfort, right? Having some control, some autonomy. Whereas, currently the way we have mechanical systems designed mostly around the world, the individual in a space, in a workspace, has no control of what their climate control is. It's pre-programmed, it's going by some master control, and people that they have fixed windows in most commercial environments, so they don't have the ability to open a window. They don't really have the ability to control their climate at all. So
Yeah, that
the psychological part is probably a big piece of this, right? Feeling that
it,
you
it,
have some control.
it's a big piece. But on the other hand, we also know people don't want to control all the time. If the system was not well designed and they had to do the control all the time, they will be disturbed. So if the system is perfect, they don't have to control. But there must be a possibility for them to control. You're right. If they don't have this possibility, they will be, they will not be so acceptable for the indoor environment. So to be able to go in and do changes regarding if you have a radiant heating thing or setting of the air velocity of the outlet and other things, that should be possible. But if we can make as much as possible with automatic control, I think that will be an advantage also for the people.
So this is interesting. From what I'm hearing from what you've just talked about in terms of the two systems that were started up by companies in Denmark and in the United States, those are not currently available. Are there other commercial PECES systems that are on the market?
Yes, there are different systems on the market, both in Europe and the US. There has been some development, for example, on desk fans. There are many more desk fans now which can provide increased air velocity at a low energy use. So there has been focus on how can we reduce the energy use for the fans to increase air velocity. So that's one thing. There's I think a company in the Netherlands selling workstations with built-in lighting and also some heating and ventilation outlets. So there are systems. And one system I haven't talked about, which also is a personalized environmental control system, is a chair. There are chairs on the market, heated and cooled chair. Heated chair is not so difficult because you can have electrical heating even with batteries. So you don't need very much heating because you're not trying to warm up the person. You are trying to reduce the heat loss from the person. So the person still wants to lose heat. So you don't need very much heating. Again, here the cooling is the critical thing. Some cooling on a chair can be you have a small fan in the back which are sucking air out. That also helps when you are sweating, you will evaporate better, and so there are chairs on the market for heating and cooling. I know both in Europe and in the US. So there are systems on the market. What I would like to see is, and I don't think that's on the market, like a desktop. You have like a unit you just can put on your desk, and then you have some heating and cooling and some cleaned air and a good lighting.
You
And
mentioned an annex to that the International Energy Agency is working
yeah,
on.
yeah.
Is there expectation that they may have a paper as a result of that annex?
Oh, there will be plenty of papers.
Plenty of papers. Okay.
Yes, we have. We will have on the next AIVC conference, beginning of October in Rotterdam, where we will have a topical session. Later on this year, we will have, you can stream a webinar also from AIVC on PECES. We have several, I don't know how many, but several PhD students from around the world who will be involved and who are working on things related to a personalized system. And PhD students, they have to publish. So I'm sure we will see an increase in publications. And as I said, there already exist a lot of publications which can be used. We are working on, like, say, like a state-of-the-art publication, also looking at the last 15 years research.
Oh, great, great. So, do these systems have some applicability in households?
Well, mainly the source has been using them where you have sedentary work, as I said, bank, offices. There's a lot of places where you could use them. But now that here during the pandemic, a lot of people they had to work from home all over the
Hmm.
world, and you may not really have the best working conditions in your home. So I think it's what I think is not a market analysis of it, is that there will be a need for making sure that people have good working conditions at home. There will be more and more people here after the pandemic who will work from home a couple of days a week. And that means the company will probably cut down on square meter office space. They will not have space for everybody. But then on the other hand, I know we are discussing that in Denmark. Isn't the company then responsible for making sure that they have a good working condition at home? And if you had such a desktop unit, you could just put with lighting, everything, that will solve that need. That so you're from your company, you get this unit, you put on your home desk for your working conditions. So I think that there will be a market, and especially now after the pandemic, where working home, you will work home more than you did earlier.
So currently, most of the PEC systems they're static, right? They're designed to be installed, and it's a permanent fixed installation. So what you're suggesting now is more of uh, a very almost utilitarian type device that can be moved around and put pretty
Yeah,
much in any configuration. That makes sense because also it seems like we're evolving how the workplace is, and it seems like areas need to be multi-purpose now, and things are changing, and even our architectural design.
yeah, yes. And the and of course, if you have a unit that you, let's say, easily you move around, then it's very difficult to get the outside air directly to the workplace. Then we come into the possibility of cleaning the room air by filtration or gas phase air cleaning. But I certainly see that as a good option. I don't think there's anything on the market yet on that, but I think in a couple of years we will see that also. And that's that cleaning of the air and remove particle will, of course, also reduce the risk during a pandemic of cross-contamination. One of the things we have studied almost the most is the risk for cross-contamination between people at a workplace. Because if you have your personalized, now I talk about ventilation. So either you get directly outside fresh air or you have cleaned air coming to a breathing zone, then you are not breathing somebody else's air. You are breathing fresh or cleaned air. And here again, I talked about our thermal mannequins. They are a little more sophisticated because they can breathe. They have an outside lung, but we can breathe. They can breathe through the nose or through the mouth. So when we study the effect of personalized system on cross-contamination, we, for example, can have two of the mannequins sitting at each of their workstations. One, we say, is the one who is sick. So we put a tracer gas in the expired air of this mannequin. And then on the other, we can measure how much of this expired air is being inhaled. And then around, beside the personalized system, you may also have a general ventilation. And now we can exactly say what are the risks for cross-contamination. And I think this is certainly something that will be of interest, especially for this personalized ventilation.
That's fascinating modeling, being able to do that, especially now in light of, having dealt with this global pandemic. That's information that seems to be super valuable to be able to really quantify.
Yeah. Yes.
So I was wondering, you had mentioned a pandemic, and a lot of the companies that are working on redesigning their workspaces are trying to become pandemic proof. And I'm not sure it's possible, but that's what their aim is. Will a PECS system protect you or protect the workers in a pandemic situation?
It will, if everybody has one.
Mm-hmm.
Because if, let's say, if there's only that two person has a system, then the others may get infected by the air they are exhaling. So here you should then talk about, and that's something which are being discussed also. One is the air supply to the breathing zone. But how can you remove the exhaled air so it doesn't disturb the others? If all the others, they had also a personalized system, so then they would be protected. But if there's somebody who doesn't, then there will be air in the environment from the exhaled air from the others. Mm-hmm. So it could be an idea also to look at how can you remove exhaled air.
So currently the systems don't really incorporate the exhaust ventilation in those personal environmental systems.
Well, there's exhaust ventilation in the general ventilation.
Okay,
but
it's general.
There's no local exhaust.
Got it.
Mm-hmm.
Yes, that's how we look at it. And so one of the, now I just see you with a microphone here at the side.
Mm-hmm.
We have also worked with introducing the air directly to the mouth.
Oh.
So and we have seen positive effects on that. So the air comes in, you have some tubing coming and goes out. The same with the microphone is.
That
So
is
almost similar to
interesting.
the way somebody would have oxygen provided, in a
Yeah,
hospital
but it's
setting,
not.
right? But not
Yes,
not as invasive, obviously, not stuck in your nose.
no, it's just that it is clean air, not many particles or other
Sure.
substances.
Interesting.
We always have enough oxygen in the air. Many
Sure.
people think that the problem is less oxygen. That's why we need to open windows and ventilate. There's enough oxygen.
Could you follow up a little bit on that one? Because I know there's a lot of people asking about, should we be opening windows in, say, classrooms in North America? And I hear what you're saying, but how can you address that concern that they're not getting enough oxygen?
Yeah, but they think they're not getting enough
Right,
oxygen.
right,
Yes, but the concern is that they have air with very high CO2 concentration, maybe a lot
right.
of VOCs and other stuff, and you basically want to dilute that down to concentration which are not disturbing for your learning efficiency or for your comfort. It's rarely that it's a question of oxygen. Then you go down in submarines, where they may have very high CO2 levels, still within health limit. There you may be able to talk about something with oxygen, but in normal spaces, not really.
Yeah, we'll have to have you back to talk about that one because I know that there's been a lot of discussion in here, in particular in schools, with CO2 monitors and all sorts of other things, opening windows and so we'll talk about that perhaps another time. But
Yeah,
I was because that's a whole nother topic.
yeah,
Are there any standards addressing PECs at the moment?
very, very little. I think in ASRI 55 it has been discussed. I don't know how far they are.
Hmm.
We have in an European standard, in an ISO standards, which are more or less the same, which we are just now starting to revise. We have in the guideline to the standard, not in the normative text, but in the guideline to the standard, we have introduced some requirements to personalize systems. Some first design guidelines, but this is really lacking. And that is something we want to get out of this work in the annex,
Hmm.
because the design here is different. As I said earlier, normally we design our spaces for an average person, but now we have to design for an individual. So we have to know something about what is the range of individual preferences, or how big a temperature range can we expect people to want the setting, and the same with the air and maybe also with the lighting. So we have to know more about individual differences. We have data about that. So I think it should be designed so we can, let's say, operate plus minus 3 degrees C, which is a lot. So this is a critical thing to how do you design for an individual, or how can you make the system so an individual can find its comfort temperature, and that you have enough capacity for heating and cooling, and so you can meet those requirements. So now we have to start looking for, from data we have, how big the differences are between people. And the idea is, and that's one of the topic also of this annex work, that we should come up with some better design guidelines. And so we will do that at the same time as the standards are being revised. The question also is, we say, okay, if you provide the air directly to the breathing zone of people, then we don't need to ventilate so much. We can decrease the ventilation rate with a factor 10 or so. But how do you prove that? And here we're talking about what we call the ventilation effectiveness. And that is how efficient the outside air is getting to the breathing zone. For most systems we work with today is fully mixed. So this has an efficiency factor, you can say 1. We have something called displacement ventilation, where the air is coming in at the floor at a little lower temperature than room and slowly moving upwards and pressing out the outside air. We may get up to an efficiency of 1.2, so you can reduce the amount of outside air with 20%. But for personalized system, we are talking about an efficiency of 2 to 3. So you should be able to decrease the amount of outside air with a factor 2 to 3. But we need to have a testing method to show this ventilation effectiveness. And what you do is you can do it with tracer gas and so, but we need to set up a test procedure so it can be evaluated and not just a postulate from manufacturers and so.
You mentioned a guideline. Is that guideline available? Can people who are interested in this subject be able to download that?
Well, there is in the guideline to the standard, there is basically 2 pages on PECES with some design criteria. So it's very little.
Very little, yeah.
But,
so that that may come in as part of this annex, as you mentioned.
Yes. The annex itself is going to make a guideline on a PECES system and also test procedures, how they're going to be tested if you want to compare them.
Bob, you have a question?
Nope.
Okay, I was wondering. We're running down to the last few minutes, Bjorn. In your opinion, what is the future for personalized systems?
No, I believe in that there is a future. And the thing we add now is really to bring it from a research environment into commercial products. As I said, there are some products on the market you can call personal environmental control system, but I think there is a need for a system which can really deal with all the 4 environmental parameters. So there is a need for some more guidance on how do you integrate a personalized system with the general environmental system you have. Except when we are talking about residential building, then offices, they also have a general system. So, and the idea is here that you can scale down on the general system, but how much? Because that's important when we talk about energy. If you want to show, if you have a personalized system, we can reduce the amount of air. We don't have to heat and cool so much the ambient, but we need to know how much. So there's some, especially design guideline is needed. And then is the case, can we provide any cooling in besides the cooling you get by increased air velocity? Maybe the increased air velocity could be enough. So should it always have a desk fan? Or is it so you can make the outlet where you have fresh air, you can change from getting fresh air. In another case, you just change it to like it is a desk fan. These are and how good can you work with using air cleaning and filtration instead of getting directly outside air, because then it's easier to apply in practice. And this step from getting from the, let's say, research systems to more practice is something which we'll also work on in this annex, but that's something where you need to get industry involved and have a project with industry, how it can be implemented. So I think, and especially now, we talked about this with the pandemic, risk of cross-contamination. I mean, all data we have show people have higher productivity using a personalized system. They feel better comfort. All goes in the positive, but we need to get it commercialized.
Yeah, I think that is the next step. One last question: do you anticipate that this will be more of a new construction type of innovation, or do you think that you can do some retro design on buildings that are currently existing?
I think there's something you can put into existing buildings, especially because if we can make it autonomous, so you you have a unit, you just hook up electricity, and that's what you're doing. Then definitely think it has a potential for renovation also.
Great.
The tricky part would be the outside air, right? Being able
Yes,
to retrofit with that. So, but
yes,
maybe the more standalone units that use, sorbent gas phase filtration,
that yes,
because then you eliminate all that ducting from a centralized
yeah.
location.
I mean, you could have these sorbent air cleaners. They of course have to be regenerated. But if you had a unit, you could just hook up, and then after each week, they have to be regenerated.
Mhm.
The next Monday, you have a fresh one. I think there are potential, there are possible solutions, which I think can make it more applicable in practice.
Sounds great. Well, it's certainly been an interesting hour discussing this, and I know that AIVC, which is, for those who don't know, is the Air Infiltration Ventilation Center, is holding a webinar sometime between now and the end of the year on this subject, which you'll be a part of, Bjorn. And so I want to thank them also for sponsoring this particular session for this topic. And I, thank Bjorn for being here. So back to you, Bob.
So,
Thank
yeah,
you.
so we'll be back again next month. We never go away, I guess. Isn't that's kind of the way it is, right? We're always here, but we'll be back next month with another show. We come out with one a month typically, and again, this program, of course, is a joint collaboration between the ISIAC, International Society of Indoor Air Quality and Climate, and the Indoor Environmental Quality Global Alliance, IEQGA. So we're able to, bring you the show, via all the efforts on these two organizations. So until next time, I guess I'm Bob Krell, founder and publisher of Healthy Indoors, and for my co-host Don Weeks, who is the president of IEQGA. We thank you very much. Thanks so much for joining us, and we'll see you again soon.